All right. Okay, families of functions have a structure. What's at the head of a family usually?
The dad.
Dad and mom, right? Parents?
Paycheck.
Okay, so paycheck. I hope that's not what governs your family. So we will start with the parent functions. Basically what you're doing here is, it's probably best to just have these memorized. And most of you will have most of them memorized already. Okay. But there's like 6 or 8 different graphs that you'll want to know, and then all you do is adjust them side to side, up and down, make them wider, skinnier, based on the criteria. Okay, so the parent functions, first of all, we can start with, let me get the grid up here, the constant function. Okay, that would just be a horizontal line. That might need to be white. Actually, don't put that on there yet. I put in the right spot. It's y equals 0. All right, so this is the constant function. Y equals 0. Okay. So just know that. What happens if I add 2? Moves up 2, right? What if I subtract 3? It moves down 3. Okay, so that's one of the themes you'll see. If you're subtracting from the y value, it's up, just a movement up and down. How about this one? Y equals x. Okay, that's, again, you know those, right? You know how to graph linear functions already?
Yeah.
So we're not going to address those two very much today, but they are parent functions. You can move this up and down, right? Can you change the slope? Okay, so that's what happens. So this is the parent, and the children would be different variations of it. Okay, it's called family functions. All right. Does that look familiar? It's a parabola. So this is called a parabola. The function is called a quadratic. Right? That's your parent function. Again, what can we do? We can move it up and down, left and right. We can make it wider, skinnier. I'm going to show you how to manipulate those. Okay. What else do we have? We'll put one more on here. Anybody know what that graph is? Yep. Whoa, don't fall. Well done. Resisted. Okay, so that's the parent function for x cubed.
Is your microphone on?
Yeah.
Got it. You already turned it on.
It's on. I turned it on. The funny thing about x cubed is you don't just move it left, right, up, and down, or make it skinnier or wider. You can also put humps in it. Okay. So, but we're not going to worry about that yet. But just know that that's coming down the pipeline as well. Okay. It's all right. Well, that's good enough for now on those. Any questions there? Again, hopefully you've seen those before. Okay, we got a few more here. What is that one? With the you want me to write that down with the two things?
Yes. Good. Yeah.
Absolute value.
Yes. Okay, thank you for using the right math.
I think with the two thingies.
Absolute value, right? Know that parent function. These are very easy to graph, knowing that parent function. What's the slope of that function over here?
1.
Slope is 1. What's the slope?
Negative
1. Okay. So they're always opposites, right? 1 and negative 1. I think that's the ones that you're probably familiar with. Here's a couple that you might not be familiar with. Seen that before?
Yes.
Quit acting like a 5-year-old. We're trying to be serious here. It's a square root function. Okay? So. And again, if you run into these and you don't know what they look like, you can always graph with the table. What's the square root of 0? 0, 0. Square root of 1? 1, 1. What's the square root of 2?
4.
That's 2 squared. The square root of 2 is 1.414. So at 2, you're going to get a decimal. But you can go out to 1, 2, 3, 4. I should have a dot at 2, right? Square root of 4 is 2. So if you get out to 9, it should be 3. And so you can still graph these.
What happens when we have like -4?
Oh. Anybody care to answer that question?
-2.
That's
an imaginary number.
It's
It's imaginary numbers. How do you
Okay,
graph it?
right, exactly. So we are in the real numbers right now, the real plane. So -4 is not in the domain, right? Remember that word? So we don't even worry about it. I could show you the complex plane if you wished, but we don't need to worry about that. The complex numbers turn this x and they turn the y into an imaginary number. So you would have -4 and then your answer would be 2i, 1, 2 of the i's. Right? Good question. Don't need to worry about it yet. Complex analysis. Bad memories. Okay, so that's the square root function. Mr. Jansen.
So the constant function, y equals 0, don't have a kid, right?
No, its children would be like y equals 2 or y equals -3, right? There's one more. That I'm gonna hold you to.
Would x equal 0 be
I just have to go look, I guess. Of course, that's what it is. It's a rational function. Do you remember what a rational number is? It's one of those F words in math. No, the other one. Fraction. This is called a rational function because it's a fraction. Okay, the graph. Now again, you can graph these with the table if you want. Can I plug 0 in there?
No.
Oh, we're not, because it's undefined. It's not in the domain, so we're not going to have anything on 0. But what if I put 1 in?
Yeah.
1.
1. What's 2?
1/2.
1/2. Right? What if I put in 4?
1/4.
Okay, so it's kind of going now. Will it ever cross this axis?
No.
Nope.
That's
Okay, what if I put 1/2 in?
to what? Oh, that? 1/1/2.
Yeah, which is 2. Yeah. So it's going to go like this, actually. And I can do the same thing in the negatives.
Oh, it's one of those kind of.
Oh, it's
That is a rational function.
Those are ugly, like Micah.
Yeah, well, matches the rest of the town. You know where I got that, right? Toy Story. It's the insult of the year from that movie. Okay, so those are what, 7? Right, 7 of them. There's one more that I don't bother with
No, I got it.
because we don't worry about it. It's called the step function. You'll probably see it in your book. It's got these funny brackets on it, right? It's called the step function. And it looks like a staircase. Which one's open? Well, see, I don't even bother to remember them, so. Basically, it's or the greatest integer function. Okay. It's called the step or greatest integer. So basically what you're looking at is if the x value is from 0 to 0.9999, the greatest integer in that set. An integer is a whole number. So from 0 to 0.999, what's the integer? 0, right? So you just map 0. So 1 to 1.9999, what's the integer? Map 1. Map 2, map 3, map 4. All right, -1, -2. Okay, that's the greatest integer. Again, we don't run into it much. There are some applications of it, like tax brackets and stuff, but if you need to know that for your career, you will learn it. Fair enough. Okay. Those are all the parent functions I'm going to hold you to.
Because there's 12.
Okay? So, best to have those memorized. Yep. This is where it gets interesting. Okay, let's start with the parent function, right? Absolute value x. Now we're going to start moving and shaking. What if I negate a? The what? Yeah, negatives are a real downer.
Don't win the money. That's a knee pattern, not a knee slapper.
Okay. So, oops. This is a mathematically, okay, negatives are a real downer. If you want to memorize that, fine. Mathematically, this is a reflection over the x-axis. Okay. I can show you this. It's not going to do much. What does that do? It does something. It just you just don't see it. It's a reflection over the y-axis. All right. So it's actually going to be the same graph because we're just reflecting. Okay. So this is a y-axis. Now that will matter when you get to something like x cubed, right? You reflect that over this axis, and it does change direction. Okay. Right? Quadratic doesn't do anything. All right. Okay. let's talk about okay, I'm inside the brackets, right?
Yeah.
In here, I'm hanging out with the x. So this is an x translation. So we're moving side to side. Okay? Translate. You know that means slide it, right? Just how many units? 3 units. Which way? But it says -3.
Doesn't matter. So you go opposite.
Doesn't it just make it wider though?
No, it just moves it over.
Okay, we're going to get to that. Okay, this is the thing that confuses people the most. It is a -3, right? But inside the brackets or inside parentheses with the x, you are in opposite land. So this is a translation to the right, 3 units. Okay, and we're still on the parent function because it's just x. 1, 2, 3. Okay. So remember that part. We're in opposite land inside with the x. You're in prison.
I highly doubt that.
Let's just move on. Okay, one more here. Which way is that going to move? Up. Yeah, we're just adding 2. So are we outside the brackets?
Yeah.
Yeah, so this is adding to the y value. Okay, translate 2 units. Oh. Okay. Okay, so those are some basic guidelines. Why don't I show you one more? And then we'll move on. I'll show you how to change slope. Are you sure? Oh, do I have another color?
You have lots of colors.
Orange. Okay. Y equals. What's that going to do? You experts?
Widen that for that.
No.
No, not.
You are going
It does not make it fatter. That's the other common mistake. It makes it skinnier. Okay. Here's how I prefer to think about this. It makes it go up faster. It's steeper. It's a bigger number, it's steeper, right? The slope changes. So our slope was what with the parent function? 1. Now it's going to be 2 and -2, right?
Yeah.
So there's your steeper absolute value function. What if it was a fraction? Then it makes it shallower. So if this is 1/2, it's going to be shallower. Woo! Look at all that. You're going to be fat?
I'm already fat
I don't know if I'd say that. Oh, well, you're less than me. Okay, are we good with that? Okay. Let's talk about combining all those things, because we can combine them, right? And, come on. Oops. Why'd I do that? We want that first. Which function you want to mess with? X cubed? Okay.
Yeah.
Did you just call him a gangster? A Jew. I thought you said G. It's like, we're in parachute. Okay, we have a cubic. Let me give you a function. And you got to tell me what to do with it.
Make everything in the bracket negative.
That was good.
So it's negative x.
Minus 2.
Wait, no, you have to cube it first, then make it
Oh,
negative.
yeah.
Okay, so we know it's a cubic. Have I changed the slope at all?
No.
I have not. Okay, so it's still going to look like this. We're just moving this. Okay. How far am I going to move it?
You're gonna move it
2 to the
right,
Left.
left,
one
because
down.
we're in opposite land here.
But
Okay,
that's not absolute value.
doesn't matter.
You left it
Anytime it's in the brackets or parentheses with the x, it's opposite land. Easy to remember. What am I doing here? Down 1? Okay, so I start here, 2 left, down 1. There's my new center, right?
Yes.
And what does that do? Reflects it across the
Y. X. Z.
Z. Yeah.
If you wanted to poke you in the eye, we can do a z-axis reflection.
Yes.
The z-axis actually, third dimension. Wow, we're doing all sorts of deep stuff today.
Just let me know when you get it right.
What did we tell you? The negative's outside the brackets,
It's over the X.
so over the x-axis, right?
Yes.
Yeah.
So it's now going to, this tail's coming up here and it looks like this, right?
Oh.
There's your new function.
You have to graph the points, or do you just find the...
I'm just looking for sketches at this, on this, okay?
Oh,
We're not being perfect. Now, do we need to be somewhat close?
Yeah.
You just said you want to sketch it.
If I graph this,
Trust me.
am I gonna give you credit for that?
Absolutely.
No.
That's exactly what I just
I'm gonna give you a half credit because you got the movement right, but not the slope. Okay? Well, you get 3/4 because you got most of it right, but be close, okay? And most people have no trouble being close. It's just, if you want to test me, go ahead.
I wouldn't want to
Move
be
it to
this
the left and one
Yeah.
down, right?
So I moved it first,
But then, would you reflect it, so,
and then I reflected it.
so the negative...
Right, so the parent function moved would look like that, right?
Oh, okay.
So if I just move this, that's what it would look like.
Yeah, yeah.
Now I reflected it, and it flips things. Okay. Got to have a little bit of a visualization, okay? So, what else can we do here?
state of mind.
Again, just moving these around in different ways. It's the same methods for every single one.
Find the parents' children.
Okay. Yeah, pretty much.
Look at the job.
Okay, squared x, right? What happens if I
You're going to go up 1 and something 3.
Okay, again, does this make it go up faster, right?
Yes.
Okay, and what does this do?
You're going to translate it off 1.
Okay, so my suggestion here is always translate first, right? So I'm taking my basis, which is, I'll just use 0, 0 every time. Move it up 1. There's where I'm starting, right? So translate first.
Maybe on the thing.
Okay. And then this makes it 3 times taller, right? It goes up faster. So if I have x is 1, what's my y value? 4. 1, 4. Okay. So, and then if I put 4 in for my x value, I get 7. Right, so you can see how much more of an arc is created when I multiply that, right? Bigger, goes up faster.
Right.
Here's one that'll really bake your noodle.
I don't think we bake the noodles very well.
Negative x. That's imaginary.
Yeah.
Is it?
That's I.
That is not I. What's the domain?
0.
0 works, right?
Right.
What else?
One.
Does 1, can I put 1 in there?
No.
No, I can't.
Seven.
Oh, 4.
Nope, negative 4.
Negative 4.
Who said that? Yeah.
We said?
Say it again. You can put a negative in there, what does it make that?
Positive.
Oh! Holy moly. No, but, okay, so what is it, what happens if I put, no breaking, a negative in the brackets, parentheses, root?
Nothing.
Y-axis reflection. So learn that. What am I going to do?
Keep adding on.
I'm doing a y-axis reflection. That's it. Same method for everything. You just need to apply it to the function you got. Okay?
Wait.
Y-axis reflection. Put a mirror in the middle. Are you okay, Mr. Jensen?
Yeah. No. Yeah.
No. I'm pretty sure that would be a no, even though he said 2 different things.
I think I know what you're okay with this. I am too.
You know what's helpful? If you don't break my game next time.
I highly suggest using colors. Because on some of these, you're going to have 4 graphs on one piece of graph paper, one problem. Distinguish them with colors, because that's what I'm asking you on your test. Right, so you can get used to it. Okay, I think that's it.
No homework because this is difficult.
Just because Amelia said no homework, I'm going to give you some.
Familiar.
Hey.
I'm kidding. Love.
I'm going to kill you. That's kind of a contradiction in terms.
I gotta.
I'm going to kill you
We get to learn.
with kindness. Like,
I can say that.
I already did your homework.
Yeah.
I think
No. I'm talking about teaching a little kid. He was like, no.
13 to 52. No, 13 to 27 odd.
here's my kind action for the day.
We can use.
It's not due until Thursday. We are going to do something tomorrow called forensic functions.
Oh wow, we're meeting the missing child's friends.
Yes, I meet an evil like that. 13 through 270. Have fun. But it's not due till Thursday. So that should be hard.
We're meeting the missing children's friends.
Again, if it's not on graph paper, you do not get credit. So if you need to stamp some paper up, get her done. Okay? Please do.
But you said you had it in the home. I do, but I'm totally running out. done one homework.
All right.
I've done only 3 homework.
You have about 10 minutes. Use your